Good morning, students. I hope my screen is visible and I'm audible. Can you just confirm? Okay. Thank you, Abhishek, for the response. So, yesterday we have seen the uses of static and then how do we connect Python with Oracle database with the use of cx underscore Oracle module. And then we have seen the steps involved for connecting Python with the database. So, first we are supposed to import this cx Oracle module, and then we are supposed to create the DSN by using cxoracle.makeDSN. So where DSN stands for data source name, and I have shown you how to find the values that we have to pass to the makeDSN method. We have to pass three values: the host name, the port number, and then the service name. So I have also shown you the tnsnames.ora file, how it contains all these three values. And then we have seen how to connect, how to create connection object by using cxoracle.connect and three mandatory arguments and one optional argument, that is username, password, and the DSN that you are going to create in the before step. These are the three mandatory arguments, and fourth argument it is optional, that is encoding specification is optional. And next we have created the cursor object, and using the cursor object we are executing the SQL queries. And then we have seen how we are able to create tables into the database, insert values into the database, retrieve values from the database, and I've also said you how cursor we can use it for retrieving the records from the database. So I have shown you the simplest way, that is by using simply for row in cursor. I have directly printed the rows, or else if you want column by column you can just use this row of 0, row of 1, row of 2, something like that. Column by column also you can retrieve. And by seeing the output we also interpreted that whatever the data that we are going to get from the database, we are going to get in which type? Tuple type. So that also we understood. So the data that will be returned from the database is going to be in tuple type. So apart from the direct use of cursor, you are also allowed to use the inbuilt cursor method, that is cursor.fetch1 for fetching one record at a time, cursor.fetchMany of n, so where n is going to be the size, that number of records you are interested to get at a time, and cursor.fetchAll, which also can be used to fetch all the records at a time. So these are the three inbuilt methods of cursor in order to process the result. Just like how you have result set in JDBC, here we have cursor.fetch1, fetch many, fetch all methods in order to retrieve the records. And lastly, once processing of results is completed, you know what we are supposed to do. We will be closing the cursor and the connection. So that's what we understood. And also we have seen the uses of static, that is creating a static variable and then creating static method, the two ways I have shown you. And we understood that static variables or methods are bound to the class and not to the object. So that's what we have covered in last discussion. So I hope you already understood what we are going to discuss today. So today's discussion is on regular expressions, lambdas, and then map. So I'll begin my discussion with the lambdas first, and then map, and then I'll end up my session with discussing on regular expressions. So I'll show you how we are going to use lambdas and map, because these three are very powerful in Python in real-time application development, or even in the programming exercises. Mostly you require these three: lambdas, map, and then the regular expressions. Very powerful utilities of Python programming that will be useful for logic building exercises as well. So first of all, before getting started with the lambda, first of all, what is lambda? What is a lambda, and why do we require lambdas? What are its advantages? Let's cover a simple 2 to 3 points of discussion, and then we start writing a lambda functions, and then we will also see where these lambdas are useful in the real application development. That's what first I will discuss, and then we shall move on to map. So first of all, what is a lambda? So basically a lambda is a small anonymous function. Lambda is a small anonymous function, just like the functions which you are defining with def keyword. The same way here also you can define lambdas. But the point to be remembered here is we are not going to use any def keyword for defining lambdas. We directly use the keyword lambda. And as I just said you now that lambda is a small anonymous function, thereby you must be understanding that this lambda will not be defining any name or named functions. You can just understand that we are not going to define any named functions, because with the def what are we doing? We are saying the function name, and whenever and wherever we require that, we are calling it by its name. But coming to lambda, as mentioned, these are anonymous functions. That means they will not be having any name. So when they don't have any name associated to it, then how you are going to use it? That's what the question, right? Because if at all it's normal regular functions, means we know that we are going to associate some name to that function with the use of keyword def, and wherever whenever I require that, I'll call it with its name, since it is associated with some name. But coming to lambda, we are saying it is an anonymous function, which is nothing but nameless function. So when a function is not going to have any name, then how are you going to call it wherever whenever required? That's what the challenge is. So the answer is, so what we are going to do is, whatever the lambda expression we are going to write, that particular expression, we already know that any expression will be evaluated to single value. We know the fact that any expression, irrespective of the length of the expression, it will be evaluated to single value. So what we are going to do is, whatever the lambda expression we are going to write, that expression's result we are going to store it in a variable, and this variable we are going to use it for calling the lambda function, for calling the lambda function. So this is what the point need to be understood. And the next question is, how many number of arguments you can pass to lambda, and how many expressions you can associate with lambda? These are the two questions that need to be addressed. So the answer is, you can pass n number of arguments to a lambda expression. You can pass n number of arguments to lambda. And how many expressions you can write in lambda is, the answer is only one. The answer is only one. So lambdas can be used only when you have single expression. You can apply lambdas only when you are going to write some function that is going to contain only one single expression. So these are the points you need to remember. So lambdas are anonymous functions with n number of arguments taken, but applied only on single expression. I hope everyone understood this statement. So it's an anonymous function that takes n number of arguments but applies only on single expression. And Since we know the fact that expression will be evaluated to single value, whatever that expression evaluated value is going to be there, that I am going to store it in some variable which I am going to use it wherever whenever required. Now the next question is, why can't we directly go to function when we don't have any name associated to this? There are two reasons. There are two reasons for this. First thing is, usage of lambdas will slightly improve the performance of the code. Usage of lambdas wherever possible will slightly improve the performance of your code. This is the very first and important advantage that need to be remembered. So wherever possible, if your function can be substituted by lambda, then you must use lambda in place of function, so that your overall code performance will be slightly improved. Also, the lines of code will be reduced because you are saving memory also. I hope you can understand, because I am not associating any name to my function. Since it is an anonymous function, I can even save memory also. So this is the point need to be understood. So as mentioned, the first and foremost advantage, you are slightly improving the performance of your program, reducing the lines of code, saving the memory by not associating any name that has to be stored in my local memory. Because if I am writing a function def some name, that name must be stored somewhere, right? But here I am not going to store any that particular name, and every time I call also I am directly going to call it with the variable. And what is that variable? The variable which is going to contain the result of my lambda expression evaluation. Whatever my lambda expression will be evaluating, that result I am going to put in a variable. So that's what how you are going to use. And where you are going to apply these lambdas is, in most of the cases in real time application development, we require to pass function itself as an argument to another function. In real time, there will be certain occasions where we require to pass a function itself an argument to another functions. In such cases, lambdas will be very essential and helpful, because as mentioned, this lambda expression you are going to assign it to a variable. So I can just treat that variable as a normal parameter that can be passed to any function argument, that can be passed to any function. And in real time also, mostly lambdas we use it to pass as parameter to the map. In shortly we are going to discuss about map also anyway. So basically map takes function as one of the parameter. Basically map takes function as parameter, one of the parameter. So in that case we can pass this lambda as parameter where function is expected. I hope you are able to understand. So that's where lambdas come into picture, which are very powerful in improving the performance of your code, reducing the lines of code, and even reducing the memory for storage of this particular function name. And wherever you wanted to pass the function as parameter to other functions, you can use this lambda. So that's why lambdas play a crucial role in real-time Python application development. So let us first see a very first lambda creation, how we are going to use that. I'll quickly show you. Suppose if I am saying cube equal to, so cube is the variable, cube is just a variable, and then let me say use the keyword lambda. The keyword is lambda, and suppose if I am writing a, I'm just writing cube equal to lambda a. So here a is nothing but the argument. Here a is nothing but the argument. You can pass any number of arguments. Right now I am just showing you the very first example, which is going to take only one single argument. We will see one more example with taking more arguments also. Colon. So colon is how you define a block. We already know that, but here I am not going to press any enter, because for lambda expressions you directly give an expression. So here I am going to specify something like this: a into a into a. That's it. You don't even need to mention the return. You are not even going to mention return. The reason is, by default, lambda will be performing only on single expression, and that expression will be evaluated to single value only, because we already have studied expressions. Any expression will be evaluated to single value, and that value now is getting stored in this queue. So that's what you just need to understand. So now this is it, we are done. Now for executing it, I have to call this function, right? Because for invoking I have to call the function. Now how I am going to call is, so print cube of, let me say 5, something like this. Print cube of 5. So here you can see cube is the one which is storing the evaluated expressions result, and here in the brackets I am passing 5. So actually cube is not the actual function name. It's not the actual function name. It's just the variable that is holding the anonymous function's value. And here before brackets you have to presume that there is nothing name. It's the whatever the cube you are seeing, it's the variable. That's what you need to interpret. It's the variable, and here directly we are calling the function with value 5. That's what you just need to understand. So cube is just a variable. You can't treat it like the regular function name. You can't treat it like the regular function name, because when we are saying def space and function name, there you have to understand it is the function name. But here this cube is to be treated like variable, which is going to uh, get the value that the lambda expression is evaluating. And here I am passing value 5, which will be for a, and then it has to perform the cube of this. So let's run this and see. So here you can see very simple lambda how it is being performed. So not only single expressions, you can also perform something like this cube. Okay, let me say area something equal to lambda x comma y colon, and let me just say x into y, that is some area of rectangle, something like that. And now here I can just say print area of 3 comma 5, that is the length and breadth values I am passing. So to the area I am passing the length and breadth, and then I'm just calculating that particular area. So this is how you can perform lambdas. So the only point I want you people to remember is, just remember the fact that you can pass n number of arguments to lambda, but only one single expression can be used. This is the point I want you to remember. So n number of arguments permitted, but only single expression allowed. N number of arguments permitted, but only single expression allowed. So that's what the point. So suppose if I am saying triangle and equal to lambda, and then what are the parameters triangle requires? Height and base. So colon. So in order to calculate its area, you must be knowing this. So that is half height into base na, so into b by 2. Okay, now print, so triangle, so I have to pass this height and base, some values I am just giving. So here you can see, so there are several inbuilt functions available to you in the math module, but apart from that, wherever you would like to find the areas or volumes or cubes, because square root function and square, we have some functions which we don't have and which we require for our application. In that case, what you can do is you can define several lambdas like this. Just understand, because we have already covered this modules and packages concepts. I'm just telling you what you can do in real time. So what you can do is you can define your own module, and then you can place n number of lambdas in that particular module, and then you can import that module directly, and then you can directly use something like this. You can just treat like this. Suppose in this particular file itself I have written three lambdas: cube, area, triangle. Like this, if I write hundreds of lambda expressions and if I put them in a file and if I save it as a module, then automatically what happens, wherever I require, I can directly use like this. Wherever I require the triangle, I can directly use triangle of height and base. Wherever I require cube, I can directly call the cube of that particular value, as if it is a predefined function. I hope you are able to understand. Just like how I am using here print now, just like how I am using here print and passing that particular uh, string, in similar fashion I can also use my own functions as if they are like predefined functions. So this is the advantage of going for lambdas. I hope everyone understood the use of lambdas. Now I'll move on to map, and then you will better understand how you are going to use the lambdas even there. Now, first of all, what is a map? Map in Python, and what is its purpose? Where do we use that? So, basically, map in Python is a function which takes two mandatory arguments. Map in Python takes two mandatory arguments. The first one is the function, the second one is the iterable. I repeat, map in Python is a function that takes two mandatory arguments. The first one is function, the second one is iterable. So iterable is nothing but any collection or any particular uh, yeah, collection or string, whatever the thing containing multiple values. That's how you can just understand. And how do you how do you identify they are iterable is when it is having some sequence of values, or when it is having several other values, then you can just recognize it as a collection or a string, are the examples of this particular kind, iterable. I mean, wherever you can perform the iterator. That's how you, in simple you can understand. When I am saying iterable, you can just understand wherever you can perform iteration over the values. So now what happens is, whatever the function you are passing as the first argument to the map function, that function will be applied on all the iterable values, and then it will return you a map object. It will return you a map object. I hope you are able to understand. So map is a function that takes two of the mandatory arguments. You can pass any number of arguments, but two are mandatory. At least two you can just presume. You can just understand minimum two arguments. The first one, the function, which has to be applied over the iterable, and then you can give like this n number of iterators. You can give n number of iterators. Just understand that. So whatever the function you are giving, this function will be applied on all the iterator values, and then it is going to return you a map object. And then this map object will be an of iterable nature. Whatever the map object it will be returning you, that will be of iterable nature. So what you can do is, you can just use that map object, that can be something like a list. I mean, you can just convert it to a list type or a tuple type or something, whichever you can understand it like iterable. So that's where you will be using maps. So let us first understand with the example, then you will better get that picture. Now let me use this cube, that will be simple. So I am using this cube, and let me create some list L1 equal to, I am creating a list L1. So let me say 3 comma 5 comma 8 comma some 11. Okay, let me just save this. And now what I'm going to do is, okay, let me, okay, print. So what will we do? Yeah, we shall write this map of, and then I'm going to use this cube, and then comma, and then L1. And okay, first let me run this and see. Yeah, so what is happening is, yeah, it is coming, but the output what you are getting is map object. The output what you are getting is the map object. As I mentioned, what it is going to return you is a map object. What it is going to return you is just the map object. So if you want to display element by element, then you can just use something like this, list of. Let me just write a list of. Now let's see. Yeah, I hope you got this understood now. So here you can see this particular 125 is for this print statement, and here you can see what is happening. So I'm first saying map of cube comma L1. So here you can see what is this cube. It's the lambda function. This cube is the lambda function, and then I'm passing my collection, and then I'm passing my collection. Now what is happening? This cube function is being applied on every variable or every iterable component of this collection. This cube function applied on every iterable component of my collection, and that is being returned as map object, and that returned map object I am converting it to list. That returned map object I am converting it to list. I hope everyone understood this point. So basically this is what the point I mentioned. Map will take function as one of the argument, and then at least one iterable component, and whatever the number of iterable components you are going to give, this particular function will be applied on all those iterable components, and it returns you a map object which can later be converted to your converted to your desired type. Like here in this example I am converting it to list. I hope you got the answer. So not only on this lambdas, you can also use it on user defined functions, or you can also use it on some uh, inbuilt functions. Let me give you a simple example on inbuilt function. Suppose here I'm giving something like okay, let me give 1 point some values, and then comma 2 point some values, and 3 point some values. So this is something I have just given, and let me just use the map function again. So print, and then again let me use the same list, because in real time also mostly we will be using this list only, and then map function again, and then let me use the round function, which is inbuilt. This is inbuilt function, and then I have to pass the collection. So that's L2. Now let's see what happens. So here you can see what is happening. So it have rounded off and then returned me the list. So it is giving me 134, because here this particular value is 1.4537 something, so it is rounded to 1, and this is 2.7, so it is rounded to 3, and this is 3.68, so it rounded to 4. I hope you understood this output. So what am I doing here? So map function I'm using, and then I'm passing the inbuilt function round, and then I'm passing my collection that is containing decimal values. And now what is happening is, this particular function is returning you in map object. That returned map object you are converting it to list object, and that list we are displaying, and this is how you are able to use the map. And in real time logic building exercises, I hope some of you, those who have done this NPTEL courses on Python, joy of computing, or whatever the Python, you might have experienced this. So we will be asked to read comma separated values in real time. Sometimes you will be getting a problem statement, something like you are asked to read input values in one single line separated by comma. So in that case, what you can do is, you can use this map something like this. So x comma y comma z, something I'm using, and here I can just use map function, and then I can say, because by default input function whatever you are going to use, it's going to read in string form. So I'm using here input dot split, and in that I'm specifying the delimiter as comma. So this is very simplest example that I can give you where you will be using map. So as mentioned, in real-time logic programming, logic building exercises in the hacker rank or wherever you are going to see, you might be experiencing this. So where you will be asked to read input separated by comma in one single line, because we know that the input function will be reading input in string, which again we will be converting it to int. So here you can see what we are doing. So map function, and then int is the function that has to be applied. So where it has to be applied, it has to be applied on input dot split, something like this. And then uh, yeah, let us see. Okay, press F5. So we are not printing it, that's why you are not getting. So let me just print that, so that you can see that whether they are, or else let me add them and display. That's better to understand whether it is being done or not. So F5. So here you carefully observe. So I'm giving 2 comma 3 comma 4. Okay, 3 3 4. So here you can see they are added and displayed as 10. They are added and displayed as 10. That means here you can see that I have given three values, I mean three input values separated by comma, and then I have extracted those values only, removing the split, and then I have stored them in x, y, z respectively. That I have calculated the sum and displayed. So this is how you will be using map also. And not only normal variables, you can also use it with list also, something like this. Some L3 equal to list of, okay, let me copy this because I require the same function. I just wanted to show you not only for three variables, you can also use it for multiple things also. And then here you can just print that list also. So here now, so let me press F5. So here you can see now 2 comma 5 comma 8 comma 6 comma 4 comma 9 comma 7, something I have given several comma separated values, because in the earlier case I have taken only three values now. So too many values to unpack, just a second. Okay, first thing, because xyz I did not remove na, so I understood, because the first thing I have to give is xyz, later I have to pass the list values. So that's the reason we got that error. Okay, let me just once again give. So here let me give 2 comma 3 comma 4. Okay, and then once again we have to give for L3 also na. So here you can give multiple values separated by commas. Yeah, this is how you can give. So I hope you understood this. So here what is happening is I'm giving comma separated values like this, as many number I wanted, and then I'm able to store them in a list or variables according to the wish, and then you can process it for your program. So this is how you will be using maps in real time application development. I hope everyone understood this list and map, lambdas and map. So I'll move on to this regular expressions now. I hope so far everyone understood whatever I have covered. So let me continue my discussion with regular expressions. So let me clear my console. So now coming to regular expressions in Python. So what are regular expressions? Okay, so I don't think any lag is there. Let me continue with my regular expression discussion. So what is a regular expression? So a regular expression is basically a sequence of characters that you are going to use it like a search pattern. So when you have huge amounts of text, or when you want to check for certain pattern whether it is being contained in the string or not, then you will be using these regular expressions. That is where the regular expressions come into picture. So it is basically a sequence of characters that forms a search pattern. That's what simply regular expression is all about. So it is the sequence of characters that forms a search pattern, and it can be used to check if a string contains specific search pattern or not. That's where the regular expressions come into picture. And for using these regular expressions, Python have provided a module called RE. RE is the regular module which we use for regular expressions. So how you will be importing? You already know that import LE. You just use import RE. So import RE is the statement which you are going to use in order to import regular expressions into your program. So let me start with very simple search checking. So I'm going to use the search function. So there are several built-in functions that are available in this RE module. So I'm going to show you four of them. That is the search function, the find all function, the split function, and the sub function, because these are the four functions that we use in real time. So the search function will take two arguments. The first one is the pattern and the second one is the string. I repeat. So search function takes two arguments. First one is the pattern, second one is the string. And then what it will return you is, it will return if the search pattern is found in the string or not. It returns the match object. It returns the match object. So if the search string is found, it returns the match object. So with that you can just perform whatever you wanted. That's what you are going to perform. So let us first implement this search function and see that. So I'm just taking some string s equal to, okay, we will write the same thing what we are doing now. We are learning Python. So a simple string which we are performing now, and let me take some variable I equal to, and I'm using the imported module RE, that is the regular expression module, and then I'm using the built-in function search, and then here I'm using the first I have to give the pattern as mentioned. So the pattern which I'm going to check for is, okay, let me use this caret symbol. So this caret symbol indicates if the search string whatever we are looking, it begins with this caret symbol indicates begins with. So next I'm giving v dot star. I'll tell you about these meta characters and special sequences that we can apply in regular expressions shortly. So whatever the meta characters now I'm using, I'll tell what they are purposeful for. All that I'll tell you. So first observe this caret symbol. So this caret symbol indicates if the string begins with, what is that I am saying, v. So if the string begins with v, and dot indicates any character apart from new line. Dot indicates any character apart from new line, and star indicates zero or more occurrences. zero or more occurrences of what? This dot. What is this dot? Any character. That means after v, you can have any characters any number of times apart from slash n. Apart from slash n. That's what this dot star indicates. That's what this dot star indicates. And next I am going to give something like Python dollar. Let me just use Python dollar. That means dollar indicates end of string, just like how caret symbol indicates begins with, similarly dollar indicates ends with. Dollar indicates ends with. So I'm and I have to pass the string object. I have to pass the string object. So here once again let me explain you. So here I am giving the search pattern, and search pattern to be on string yes, search pattern to be checked on string yes. So and here you can see what we are asking the search pattern. So if this particular string yes begins with v and dot indicates any character, zero or more occurrences, and dollar indicates ends with, so it ends with Python. So this is what we are doing in this search. And then what we can do is we can just use this regular if else style, and then I can say print match, otherwise I can say no match, something like that, very simple. So I can just say so let's run this and see. So here you can see you are getting it match. Suppose if I just replace this capital W with a small w, can you see my output now?